The following Zoom session is being recorded and will appear later today on my YouTube channel, Math with Mayo. Therefore, when you participate in the Zoom meeting, if you do not wish for your picture or your name to be made public, please leave the video off and use an alias name. If you have questions during the meeting but do not wish to speak, email me at bmail@ybcc.edu and I'll respond as soon as I can. All right, today we're going to take a look at section 10.2, the first part, and it deals with something called the quadratic formula. And what I want to do, first of all, is to show you how the quadratic formula was developed. If we start out with a general second degree equation, it would look like this. ax squared plus bx plus c equals 0, where a, b, and c are the corresponding coefficients to the three terms. All right, now we're going to take this general equation and we're going to use completing the square to solve it for x. Keep in mind, a, b, and c are the numbers that would be the coefficients of the terms. So the first thing we're going to do is we're going to divide each term by a, so that we have a leading coefficient of a1. So now we get x squared plus b over ax plus c over a equals 0. The next step is to move the constant term to the other side of the equation. So we're going to subtract c over a. So we'll get x squared plus b over ax equals negative c over a. Okay, the next thing we're going to do, we're going to take the coefficient of x, which is b over a, right? This thing right here. We're going to divide it by 2, which is the same thing as multiplying it by 1/2. So we get b over 2a. Then we're going to take b over 2a and square it, which gives us b squared over 2 squared, which is 4a squared. Okay, so I'm going to add b squared over 4a squared to both sides of the equation. Now, on the left side, I've got x squared plus b over ax plus b squared over 4a squared equals, on the right side, I'm going to take these two terms, well, we'll just leave them as they are right now. To add them, I need a common denominator, which would be 4a squared. So what I'm going to do is I'm going to take that first term right here and multiply it by 4a over 4a. So my new numerator becomes minus 4ac. Okay. Now, on the left side of the equation, I should have a perfect square whose factors are x plus b over 2a times x plus b over 2a. Recall that the number that goes with the variable is the quantity that we square. Okay. On the right side of the equation, I'm going to switch the order of these two, and I'm just going to write them b squared over 4a squared minus 4ac over 4a squared. You could do it either way, but it just comes out cleaner this way. So now on the left side of the equation, I've got x plus b over 2a, the quantity squared, equals. On the right side of the equation, they both have the same denominator, so I could write it as b squared minus 4ac all over 4a squared. Okay. So what did we do? We divided both sides by a. We moved the constant term to the right side of the equation. We took the coefficient of x, cut it in half, squared it, added it to both sides, massaged the numbers to get a common denominator, etc., etc. So now at the bottom of this page, I have a perfect square equal to a constant. Remember, a, b, and c are all numbers, so that right side is just a number. So now I'm going to recopy that on the next page. So I've got x plus b over 2a, b over 2a squared equals and that is b squared minus 4ac, b squared minus 4ac all over 4a squared. I'm going to take the square root of both sides of the equation. So on the left, I get the square root of that quantity squared. On the right, I get plus or minus the square root of that quantity squared. Okay. On the left side, I now have x plus b over 2a. On the right side, plus or minus, I'm going to take the numerator and the denominator and split them up. So the numerator is b squared minus 4ac. The denominator is the square root of 4a squared. Okay. So now I've got x plus b over 2a equals plus or minus the square root of b squared minus 4ac all over. Well, the square root of 4a squared would be 2a. I'm now going to subtract b over 2a from both sides. So x equals negative b over 2a plus or minus the square root of b squared minus 4ac all over 2a. But notice that both terms on the right side of the equation have the same denominator. So I could rewrite this whole thing like this. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And that, ladies and gentlemen, is called the quadratic formula. It can be used to solve second degree or quadratic equations. You're going to want to memorize this formula. Okay, now I'm going to go and take a problem and solve it by factoring to show the answers. Then I'll use the quadratic formula. This is not a great example to show you how great the quadratic formula is because it takes longer than the factoring in this case, but it will show that it works. Where does the quadratic formula come in handy? When there's a problem that's difficult to factor. Okay, anyway, let's take the following. X squared plus 5x plus 6 equals 0. To solve this by factoring, we have x plus 3 times x plus 2 equals 0. So we get x equals negative 3 and x equals negative 2 accordingly. All right. Now, using the quadratic formula, x equals negative b plus or minus b squared minus 4ac all over 2a. We're going to consider this equation and take note of the fact that a is 1, b is 5, and c is 6. It's in standard form. That's important. Once it's in standard form, descending powers, then the coefficients a, b, and c. So x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Again, I'm substituting the numbers for a, b, and c in the quadratic formula. Continuing to simplify, x equals negative 5 plus or minus the square root of 25 minus 24. 4 times 1 times 6 is 24, and it's minus that, all over 2. X equals negative 5 plus or minus the square root of, well, 25 minus 24 is 1, all over 2. X equals negative 5 plus or minus the square root of 1 is 1, all over 2. So x equals negative 5 plus 1 over 2, which is negative 4 over 2 or negative 2. And over here we'll go x equals negative 5 minus 1 over 2, which is negative 6 over 2, which is negative 3. So here are the same answers. Now, again, using the quadratic formula took much longer than factoring, but there are problems that are difficult to factor or that really can't even be factored where the quadratic formula helps us. So now we're going to be looking at solving equations using the quadratic formula. Okay, so let's take the following equation. X squared, or excuse me, 6x squared minus x minus 1 equals 0. The problem is in standard form. ax squared plus bx plus c equals 0. So we've got a equals 6, b equals -1, and c also equals -1. Plugging the numbers into the quadratic formula, x equals -b plus or minus the square root of b squared minus 4ac all over 2a. X equals, well, negative times negative becomes positive, so 1 plus or minus the square root of -1, the quantity squared is 1, minus 4 times 6 times -1 would be plus 24 all over 12. X equals 1 plus or minus the square root of 25 over 12. X equals 1 plus or minus 5 over 12. X equals 1 plus 5 over 12, which is 6 over 12, which is 1/2. X equals 1 minus 5 over 12, which is -4 over 12, or -1/3. So x equals 1/2, and x equals -1/3. Okay, let's take a look at another example. X squared minus 18x plus 81 equals 0. A is 1, B is -18, and C is 81. X equals -b plus or minus the square root of b squared minus 4ac all over 2a. X equals, negative times negative is positive. 18 plus or minus the square root of, let's see, -18 times -18 is going to be positive. Let's see here. 324. And then minus 4 times 1 times 81 is also a minus 324 all over 2 times 1, or 2. So x equals 18 plus or minus the square root of 0 over 2. X equals 18 plus or minus 0 over 2. So basically we just have one solution, and we'd say that it has a repeated solution. Okay, so a repeated solution of x equals 9. All right, because for a second degree equation, there are two solutions. All right, now let's take a look at this one. T squared equals t plus 4. We're no longer using the variable x. Now we're using the variable t. So technically, the quadratic formula would be t equals the quantity -b plus or minus the square root of b squared all over b squared minus 4ac all over 2a, blah, blah, blah. Anyway, okay, we need to get it in standard form. So I'm going to subtract t and subtract 4 from both sides of the equation. So a is 1, b is -1, c is -4. T equals -b plus or minus the square root of b squared minus 4ac all over 2a. T equals 1 plus or minus the square root of 1 plus 16 all over 2. T equals 1 plus or minus the square root of 17 all over 2. Now, the square root of 17 is irrational. It doesn't break down. We can't simplify the radical. So our two solutions are t equals 1 plus the square root of 17 over 2, and t equals 1 minus the square root of 17 over 2. And as I mentioned in a previous section, in WebAssign, it doesn't use the plus or minus, so you need to list them separately, the two solutions separately. But it also says that we are supposed to approximate the solutions to the nearest hundredth. So now I want to go back, I want to recopy these on the next page and talk about putting them into the calculator. All right, so 1 plus the square root of 17 all over 2 1 minus the square root of 17 over 2. We need to divide the entire numerators by the 2 in the denominator. So in my calculator, I'm going to put a left-hand parenthesis, a 1, plus a square root of 17. Now, on my calculator, when I put in the square root of something, it automatically gives me a left-hand parenthesis. If yours does that, then you're going to also want to do this. You're going to close up with a right-hand parenthesis, but then close up the entire thing divided by 2. Okay, so you're going to have a set of parentheses around the radicand, the 17 inside the radical, and around the entire numerator, because you're dividing all of it by 2, not just the radical. Okay, so then parentheses 1 plus the square root of 17, close up the 17, close up the entire numerator divided by 2, and I get 2.561552.813. The direction said to round to the nearest hundredth. The hundredth spot would be the 6. The 1 would round down, so I'm going to get approximately 2.56. So here is one of my exact answers and one of the approximate answers. Now, the second one is going to be 1 minus the square root of 17 divided by 2. Again, I need that second set of parentheses. And let's see here. I get negative 1.561552.813. The 6 would round down, so negative 1.56. Exact answer, approximate answer. Okay. Now, let's take a look at another example. This says 4w squared plus 1 equals negative 6w. It's not in standard form, so I'm going to add 6w to both sides of the equation. I get 4w squared plus 6w plus 1 equals 0. So now it's in standard form. A is 4, B is 6, and C is 1. So W equals negative B plus or minus the square root of B squared minus 4AC all over 2A. So what do we have here? W equals negative 6 plus or minus the square root of 36 minus 16 over 8. W equals negative 6 plus or minus the square root of 20 over 8. But I can simplify the square root of 20. Recall, the square root of 20 is the square root of 4 times 5, which would be 2 square roots of 5. So this could be written as W equals negative 6 plus or minus 2 square roots of 5 over 8. Now, if I can reduce these answers, I should do so. If all the terms on the top and the term on the bottom have a common factor that I can pull out and reduce it, I will. They're all even, so here's what I'm going to do. I'm going to factor out a 2 on the top and on the bottom. Okay, so I took a 2 out of the top and out of the bottom. Then I can reduce those down. So now I've got W equals negative 3 plus or minus the square root of 5 over 4. All right, now, so the two exact answers would be W equals negative 3 plus the square root of 5 over 4, and W equals negative 3 minus the square root of 5 over 4. Again, going back to the calculator, parentheses, negative 3 plus the square root of 5 divided by 4. And again, I've got that extra set of parentheses there. And then the bottom one, negative 3 minus the square root of 5 divided by 4 And again, so let's go to the calculator on the first one. Parentheses, -3 plus the square root of 5. Close it up, divided by 4. And I get, let's see here, -0.1909. Rounding to the nearest hundredth, the 9 spot, the 0 would round down. So we get -0.19. So exact answer, approximate answer. And then here, let's see, I get -1.309016, etc. And here the 9 would round up, so you'd get -1.31. Okay, and again, there's the exact answer. So you've got 2 exact answers, 2 approximate answers. Now, another notation thing that I've seen students do. WebAssign will say, you know, write the 2 exact answers separated by a comma, and they'll do this. And WebAssign gets confused. You've got to make sure that that comma is outside of that fraction. If it shows up down below, it's not going to know how to deal with it. So be careful of that. Okay, now let's take a look at some quadratic equations that can be simplified before we plug them into the quadratic formula, just to make it easier to deal with. For instance, let's say we've got this. Now, recall the quadratic formula in general is x equals -b plus or minus the square root of b squared minus 4ac all over 2a. If a is negative, that makes it kind of tricky simplifying the quadratic equations using the quadratic formula. It's much nicer to have a positive, just like when we talked about factoring back in chapter 6. So what I'm going to do is I'm going to multiply both sides by -1, or I could divide both sides by -1. In either case, it's going to switch the signs and give me that. Okay, so now a is positive. In this particular, these examples, we're not going to actually solve them. We're just going to say, okay, here's what you can do with it. So if your leading coefficient is negative, multiply both sides by -1 to make your leading coefficient positive. Here's another example. Let's say that your equation contains decimals. You could deal with the decimals and let a be 1.6 and b equal 2.4 and c be -0.9, but it would be nicer to get rid of the decimals. In this case, I need to move them all one place. So I'll multiply both sides by 10, 16t squared plus 24t minus 9 equals 0. And then I'll use 16, 24, and -9 as a, b, and c. Another example, you've got fractions, 1/8 x squared plus 1/2 x minus 3/4 equals 0. How do you clear fractions? You multiply both sides by the LCD, which in this case would be 8. 8 times 1/8 x squared is x squared. 8 times 1/2 x would be 4x. 8 times minus 3/4 would be minus 6 equals 0. So now a is 1, b is 4, and c is -6. Let's say you've got this situation, 33y squared plus 99y minus 66 equals 0. Well, here you could factor out a greatest common factor. That's a constant, and that would be a 33. Y squared plus 3y minus 2 equals 0. Then you could divide both sides by 33. Y squared plus 3y minus 2 equals 0. A is 1, b is 3, and c is -2. So there's another instance where you could simplify the problem before you use the quadratic formula. Okay, let's take a look at some more problems. let's see, how about this one? X squared equals negative 5/4 x plus 3/2. So this equation contains fractions. Let's get rid of them by multiplying both sides by the LCD, which is 4. So I get 4x squared equals negative 5x plus 6. Again, negative 5/4 times 4, the 4's would reduce. 3/2 times 4, the 4/2 would reduce. So we get 4x squared equals negative 5x plus 6. Okay. Now, let's go back and put this thing in standard form. We'll add 5x to both sides and subtract 6 from both sides. 4x squared plus 5x minus 6 equals 0. So our equation is in standard form and there's no fractions. Again, you could use the fractions in the quadratic formula. You don't want to. Most people that do that end up not getting the right answer. So I highly recommend getting rid of the fractions. So now I've got a is 4, b is 5, and c is negative 6. So x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. X equals negative 5 plus or minus the square root of 25. Minus 4 times 4 is minus 16 times minus 6 is plus 96 all over 8. That's what happens at Thanksgiving. They all over 8. Okay, 16 times 6. So now x equals negative 5 plus or minus the square root of 121 all over 8. Okay. But 121 is a perfect square. The square root of 121 is 11. Nice. So now x equals negative 5 plus 11 over 8, which is 6 over 8, or 3/4. X equals negative 5 minus 11 over 8, negative 16 over 8, which is negative 2. So x is 3/4, and x is negative 2. All right. You want to be careful that you don't write your answer using parentheses, because then it looks like an ordered pair. Okay. All right, let's see here. Let's take this one. Negative x squared minus 6x minus 2 equals 0. So I'm going to go ahead and get rid of the negative 1 coefficient. I'll multiply both sides by negative 1. So I get x squared plus 6x plus 2 equals 0. So it changes the sign of each term inside the parentheses. A is 1, b is 6, and c is 2. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. X equals negative 6 plus or minus the square root of 36 minus 8 all over 2. X equals negative 6 plus or minus the square root of 28 all over 2. But the square root of 28 is the square root of 4 times 7 is 2 square roots of 7. So it becomes x equals negative 6 plus or minus 2 square roots of 7 all over 2. But we can factor a 2 out of each term in the numerator and each term in the denominator. It's supposed to be a 7 and it looks like a 2. Let's see here. Square root of 7, oops, all over 2. Okay. Those reduce down, so x is negative 3 plus or minus the square root of 7. So x is negative 3 plus the square root of 7, and negative 3 minus the square root of 7. Now we go to the calculator. Since we're not dividing by anything, we don't need parentheses. We can just say negative 3 plus the square root oops, hang on here, -3 plus the square root of 7, and I get -0.354. The 4 is going to round down, so -0.35, and then minus -5.645. The 4 is the hundredth place. The 5 would round up, so we get -5.65. So here are the exact answers and the decimal equivalents. Okay. Let's see here. X times x minus 27 equals 280. The problem here is that it's not at all in standard form. So let's distribute x squared minus 27x equals 280. Subtract 280 from both sides. X squared minus 27x minus 280 equals 0. It's in standard form. There's no fractions. There's no decimals. There's no common multiple we could factor out. So we're good to go. A is 1, B is -27, and C is -280. So x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Negative times negative is positive 27 plus or minus. Negative 27 times negative 27 is going to be positive, and that's going to be 729. Minus 4 times 1 is minus 4 times negative 280 is going to be positive. So 4 times 280 is 1120 all over 2. So x equals 27 plus or minus the square root of, let's see, 1120 plus 729 is 1849. That's not the year I graduated from high school. So then x equals 27 plus or minus. Let's hope that 1849 is a perfect square. Let's see. It is. Nice. 43. So the square root is 43. So x equals 27 plus 43 over 2, which is 70 over 2 or 35. X equals 27 minus 43 over 2. Let's see, what is 27 minus 43 is -16 over 2, which is -8. So x equals 35. X equals -8. Okay, let's see. How about this one? 120 x squared plus 120x minus 40 equals 0. This is already in standard form. Again, we could use those large coefficients, but we could factor a 40 out of each term, divide it out, and get rid of it. So 40 times what? 3x squared plus 3x minus 1 equals 0. Divide both sides by 40. 3x squared plus 3x minus 1 equals 0. So A is 3, B is 3, C is -1. X equals -b plus or minus the square root of b squared minus 4ac all over 2a. X equals -3 plus or minus the square root of 9 plus 12. -4 times 3 times -1 is a positive 12 all over 6. X equals -3 plus or minus the square root of 21 over 6. Can't simplify the square root of 21, so x is -3 plus the square root of 21 over 6. -3 minus the square root of 21 over 6. And so again, going to the calculator, the top one, let's see, parentheses, -3 plus the square root of 21, close up the square root, close up the entire numerator, divided by 6, 0.2637, the 6 rounds down, so 0.26, and then the other one, -1.263, again, the 6 rounds down because of the 3, so we get what, -1.26. So we've got the exact answers and the decimal approximations. All righty, that's it for today. I'll be back at 1:15 with an office hour. Hopefully you'll have a great rest of the day, and let's stop the recording. Bye.